The first, second, and third terms of a geometric progression are 3k, 5k minus 6, and 6k minus 4 respectively. 1. Show that k satisfies the equation 7k squared minus 48k plus 36 equals 0. So, since this is a geometric progression, and the first three terms are these, for geometric progression, the pattern is you multiply it by the common ratio as you go along. So we multiply it by r each time to get the next term. Therefore, r must equal 5k minus 6 divided by 3k, because if you multiply 3k by r, it will equal 5k minus 6. We can also find r from the next term as well. So that means that 6k minus 4 divided by 5k minus 6 must equal r as well, because we know that when we multiply 5k minus 6 by r, it will equal the next term. So we have two versions of r here, and we can use this to solve for k. Because we know that both of these expressions represent r, therefore 5k minus 6 over 3k equals 6k minus 4 divided by 5k minus 6. And now, all we need to do is just rearrange this expression into 7k squared minus 48k plus 36 equals 0. So if you notice, the expression that we want to rearrange it into has no fractions. So the first approach is to get rid of the fractions by multiplying both sides by the product of the denominators. So if we multiply both sides by 5k minus 6 and 3k, it cancels out and simplifies to this. If we expand the brackets, we get 25k squared minus 60k plus 36 equals 18k squared minus 12k. And in the expression that we want, everything is on one side. Everything is on the left-hand side of the expression. So if we move all the terms to one side and then simplify it, we should get 7k squared minus 48k plus 36 equals 0, which is exactly the expression that we want. 2. Find, showing all necessary working, the exact values of the common ratio corresponding to each of the possible values of k. So if we want to find the common ratios corresponding to each possible value of k, we need to solve for k first. So we can solve for k by solving the expression 7k squared minus 48k plus 36 equals 0. This is a quadratic, so we can solve by factorizing. So 7k minus 6 multiplied by k minus 6 equals 0. So that gives k equals 6 over 7 and k equals 6. So for k equals 6 over 7 and k equals 6, from the previous part, we have an expression for r over here. Right? This is the expression that represents the common ratio. So all we need to do is substitute k, the two values of k that we have, back into these expressions to find the common ratio. So if we use 5k minus 6 over 3k instead, because it's easier, r equals 5k minus 6 over 3k. If you substitute k with 6 over 7, r equals minus 2 over 3. And if we substitute k with 6, r equals 4 over 3. So we have all the answers. So that's k equals 6 over 7 corresponds to r equals minus 2 over 3, and k equals 6 corresponds to r equals 4 over 3. Three, one of these ratios give a progression which is convergent. Find the sum to infinity. So for a progression that is convergent, there is a sum to infinity because it converges to one value, or the values get smaller as you go along the progression. So to find the sum to infinity, let's first look at what we have from the previous part. We have k equals 6 over 7 for r equals minus 2 over 3, and k equals 6 for r equals 4 over 3. From the formula sheet, in order to find the sum to infinity, we need a over 1 minus r, where the modulus of r needs to be less than 1. If the modulus of r is not less than 1, there is no sum to the infinity. So the modulus of r is less than 1 corresponds to the first version of k and r. So that's k equals 6 over 7 and r equals minus 2 over 3. Because the modulus of minus 2 over 3 is less than 1. 4 over 3 is bigger than 1. So all we need to do to find the sum to infinity is substitute these values into the formula a over 1 minus r. So we know that the first, second, and third terms are as follows from the first part of the question. This means that the first term is equal to 3k, so a equals 3k, and we're using k equals 6 over 7. So a equals 3 times 6 over 7, that's 18 over 7. And r is equal to minus 2 over 3. So substituting that into s infinity gives 18 over 7 divided by 1 minus 2 over 3. That gives 54 over 35. So the sum to infinity is 54 over 35.